So I work for BioLogos, so I have to explain a little bit about who we are. As I said, Francis Collins, he is the director of the Human Genome Project and now the director of the National Institutes of Health, and he tells his testimony in this book. And there was so much interest in that from so many people. It was a best-selling book. And he got tons of questions then. How can you be a scientist and accept Christianity? So he founded BioLogos to be a place to answer those questions, a website. We've since grown into a large ministry where we have an active website, but also programs for pastors and teachers. And we have a grants program where we've given out 37 grants to individuals and teams of scholars all over North America and Europe who are investigating questions at the intersection of science and faith, and also developing materials in a lot of different contexts, different denominations, and pastors' conferences, and Christian colleges, and high schools, and arts groups, and all different places. So we're pleased to have that going out. We're inviting the church and the world to see the harmony between science and biblical faith as we present an evolutionary understanding of God's creation. And if you missed it, I talked earlier about evolution. Now we're going to talk just about astronomy. And also, even earlier today, talked about the importance of science in the ministry of the church. So there are a lot of challenges to this idea of harmony. This is one that came just a few months ago. Jerry Coyne posted on his blog. He's one of the vocal new atheists. He said, BioLogos has always fascinated me because it's an organization that has immense potential for cognitive dissonance. Somebody brought that up earlier. They're dedicated to helping evangelical Christians accept evolution. That's an admirable task. But they insist at the same time on adhering to evangelical Christianity. In other words, they promote science with one hand and promote superstition with the other. It always mystifies me how smart people can retain such primitive superstitions. That is how he is viewing our lives of faith. Well, in our view, this is an example of a very different worldview perspective than ours on science. And I'm using worldview here in the sense of the way you answer the big questions of life. Is there a God? What does God mean to us? What is the purpose of human existence? All those deepest truths, people answer in very different ways, and so they have different, what I'll call, worldviews. And yet people of very different worldviews can agree on the same scientific evidence. How can that work? So I want to, as a Christian, pursue science in a way that is integral to my faith. I don't want to set aside my faith in some sense when I sit down to do science. I want to have it be part of what I do. And yet, I'm doing kind of the same thing as all the other scientists who don't believe in God. So how does that fit together? So one way to think about that is to think about some of the worldviews and beliefs necessary for science that aren't derivable from science. Things like humans are capable of understanding nature. Okay, if you're doing science, you believe that's possible. You believe that nature operates with regular, repeatable, universal patterns. All scientists believe that experiments are necessary, that you can't just sit in your armchair and theorize about how the universe must be. And they believe that science is worth doing. These are beliefs that are necessary for science, but they're not things that you can really do experiments on and test for themselves. And people will have different reasons for believing them. An atheist might believe them because they just seem to work, or they might have some other reasons. But I believe them for Christian reasons. So I believe that we can understand nature, that that's part of being made in God's image, that God is giving us that capability of thinking his thoughts after him. Nature operates in regular patterns. I believe that is because it is ruled by one God in a faithful, consistent manner. That God's faithfulness there in his consistent governance of the universe allows us to see the same physical laws across time and space. I believe we need experiments because God's creativity is free. He could have made the universe any way he wanted. And we are fallen creatures, and we're also just limited and not able to understand it all. We can't just guess how it works. And for me, science is worth doing because we are gifted by God to do science, called to it to study God's very handiwork. So I don't set aside my faith when I sit down in front of the computer to look at the astronomical data. Instead, that's just a natural outgrowth of my faith, as it was for many of scientists who, in the early days of science, who were Christian believers. Johannes Kepler and Michael Faraday and Hoyle are wonderful examples of that. So we're studying God's handiwork. What do we see when we look out in the universe? So now we can dim the lights. And, oh, there we go, okay. Isn't that beautiful? So this is a picture of a portion of the sky. It is taken in New Zealand. What do you see in the picture? And we'll make this interactive, so go ahead and raise your hand or shout out. What do you see in the picture? Yes? The Milky Way, look at that, isn't that beautiful? It's a milky band of stars, but there's also these dark clouds mixed within it. Okay, what else do you see? There's a comet. Beautiful Comet McNaught it was in, let's see, what's this, 2007, only visible in the southern hemisphere, darn. But with modern technology, we can enjoy it too. Anything else you spot in this? Andromeda. This guy here, is that what you're thinking of? I believe that is the Large Magellanic Cloud. It is another galaxy. Yep, it's correctly identified. This is an entire separate galaxy from our own with its own family of stars. The Milky Way here is our galaxy seen edge on. So, and of course we're seeing all sorts of stars here. Those are in our own galaxy. And there's these red bands as well, which is a little bit of remaining sunset light there. When you look at a picture like this, it's easy to say that the heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge. So I believe that the heavens are declaring a lot of things about God, and that God has revealed himself in the heavens so that we might learn something of his character. So an image like this shows us his glory. So this is a roughly scale model of a galaxy. It's about, this is 100,000 light years across. So there's would be a spiral pattern on this. If you look at it edge on, it looks like a straight line. And that's the line of the Milky Way we're seeing there. So it's aligned like this. We're embedded about halfway out, but from the center to the edge. That's about where the sun is. So, and then this Large Magellanic Cloud is hovering about here. So there's a little galaxy over there. Okay, so that is some of what this image of the heavens is declaring. It's looking through a depth through that little bit of sunset light right here at Earth, the comet in our solar system, the stars that are part of this galaxy that we're embedded within, all that field of stars, and then the whole band of the bulk of the galaxy that we're seeing edge on. And then an entirely separate galaxy, many distances, all in one photo. So this is an image of the Northern Lights. How many of you have seen the Northern Lights? Oh, what a blessing to have seen the Northern Lights. So what else do you see in this picture? Do you see some of the stars back there? You see the Big Dipper. Da-da-da. There it is. If you don't know any constellations, this is a great one to learn. You've got the handle of the Big Dipper, and the N2 stars point to the North Star. Yes. Anybody know what this one is? It's Cassiopeia. Cassiopeia. And the Little Dipper is hanging around here somewhere. It's very faint. But the Northern Lights are a glorious, another beautiful display. And Psalm 19 goes on to say, there's no speech or language where their voice is not heard. The voice of the heavens goes out into all the earth, their words to the ends of the world. There's universalness to this sense of wonder we have in looking out at the natural world. I've not met anybody who looks at that and goes, yeah, whatever. You know, people look at that and go, wow, that's amazing. But then we as Christians, when we look at it, for those of us who believe and know God personally, we sense not only wow, but wow, that's my Creator, my Savior made that, and it's part of our relationship with him. Now, there's also a scientific explanation for the Northern Lights. So the Northern Lights are due to the solar wind. So the sun is way off to the side in this diagram. Energetic particles leave the sun, flow to Earth. These blue lines here are the magnetic field of the Earth, and the solar wind gets bounced around that. Some of it gets trapped in here near the North Pole and near the South Pole, and it causes this glowing ring here where the energetic particles hit the Earth's atmosphere, and that's what the glow is due to. So you get these different labels for the parts of the Earth's magnetic field. We have a scientific explanation for this. Does that make it any less beautiful? Does it make it any less glorious? I think it makes it more interesting. Like, wow, I mean, it's coming all the way from the sun. So a scientific explanation does not replace God. I mentioned earlier today the God of the gaps issue, where if there's a gap in our scientific understanding, people want to put God there, and if you put God only there, you run this risk of explaining away God. So having a scientific explanation does not replace God. It doesn't push God out. It tells us more of God's handiwork. So in Psalm 19 goes on to say that in the heavens he's pitched a tent for the sun, which is like a bridegroom coming out of its chamber. So here's a nice image of the sun all in one day, taken from a place in Athens. They took several pictures of the sun throughout the day. You can see it rising and setting there. In Jeremiah 33, God refers to this pattern of day and night. He promises Jeremiah and his people that he will not break his covenant with them any more than he would break his covenant with day and night and the fixed laws of heaven and earth. And I think our language of talking about natural laws traces back to this passage where God is talking about the laws that he uses to govern the universe. And he says that he is so regular in the operation of those laws that that's an example of his faithfulness that he will keep to his covenant. So when you see the sun rise and set, you know that you can set your clock by it. We set our clocks by what is going on in the solar system. And it's so regular, and in the same way, we can believe that God will keep his promises to us. So Psalm 19 is, as I mentioned earlier, a source of this idea of two books of revelation of nature and scripture, and as is the Belgic Confession. I mentioned these earlier. And this idea that God is revealing himself both in the natural world and in the written word of the Bible. And both of these are interpreted. We're going to spend most of our time in this hour on the science side. What is, in particular, what is science telling us about nature, and what does that in turn tell us about God? I'm not going to be talking a lot about scriptural issues in this one, but I'll refer to scripture occasionally. So where did we come from? This is a nice photo taken from the Galileo spacecraft of the moon in orbit around the Earth. And this is a true color, true brightness photo of our nearest neighbor here to the Earth. How do planets form? How do stars form? Where did all this come from? And we can say God created it, but we can also ask, well, how did God create it? So it traces back to stars. So here's a lovely photo of a star cluster. It looks like a jewel box. It's filled with all these beautiful colors of brighter stars and fainter stars, red and blue. All those colors and brightnesses tell us important things about the stars, but they're all also just sheer beauty here, seen in the universe. And I'll mention again this theme I've mentioned a few times, that God uses random variation in purposeful ways. I think this picture would be less beautiful if it was all aligned in a perfect pattern. There's a beauty to this random scattering of the lights here. So among the stars, there is more than just empty space between the stars. So to look at that, we're going to turn to the constellation Sagittarius. Sagittarius is a nice summer and early fall constellation. It's near the Milky Way, and it has this lovely teapot shape. Okay, in ancient times when it was named, they weren't thinking about teapots, but after the invention of teapots, it became the easiest way to recognize this constellation. And if you look at where the steam would come out of the spout and go up a bit, you get to the center of our galaxy, but you get to also this lagoon nebula, which I want to show to you. A nebula is a place where there is a concentration of dust and gas in between the stars, and in particular where it's been lit up, where the light of the stars is so brilliant that the gas and dust is glowing. So what looks like just a little black region on this diagram looks like this. This is the Lagoon Nebula. Isn't it beautiful? There's just an artistry here when you look at the swirl of the gases. The red color is hydrogen gas that's glowing in the light of these stars here. In this diagram, the brightness of the stars is toned down a bit so that we can highlight all of the beautiful swirling gases. And you also see these dark regions, which are concentrations of dust. It's really just a kind of smoke. It's little smoky regions in between the stars that are enough to block the light behind it and give these beautiful swirls. So it's as beautiful as any abstract painting. There's a lot of artistry here. It's as beautiful as a sunset. But it's showing God's creativity in another way as well, in that it is a place where new stars are forming. God is making new stars. So a lot of these stars are very new. You see some of them here have a bluish tint to them. Remember that, bluish tint for newborn stars, baby blue stars. But there's also stars in the process of forming. So if you look at these little concentrations of dust, the little black knots, the smallest of those would be, well, let's see, I haven't told you any of the distances here. This nebula is about 4,000 light years away. So we're seeing it not as it is now, but as it was 4,000 years ago, because it's taken that long for light to travel to us. And the image itself is about 40 light years across from one side to the other. And these little knots there would be not too far off from the size of our solar system. You know, a bit bigger, but you can picture our solar system inside of one of those, and inside those knots, new stars are forming. So it is a place where God is creating new things, and it's a sign of God's ongoing creation continuous, along with, we believe God created everything from nothing at the beginning, creation ex nihilo, but there's also all this ongoing creation. The universe is not a static place. It's a place where things are continuing to develop. So what's going on inside that little knot of gas there? Well, a cloud like that, a cloud of dust and gas, will swirl around on its axis as it'll be slowly rotating, but then it'll collapse gravitationally, it'll draw closer in, it'll begin to rotate faster, and you'll get a concentration at the center where the material is dense enough for fusion to turn on. So the gases have to be really packed together by gravity before you can get the fusion reactions that are happening at the center of any star. Once those turn on, you get a big energy outburst, and you start to see the star, the light turns on. Meanwhile, you've got still have this disk of material around that newborn star. What's it doing? Well, simulations have shown that that's where planets are coming from. So this simulates here, all the different dots are little planetoids, maybe asteroid size, a lot of other dust in this area. And over time, those accumulate, coalesce together, and form larger and larger bodies until we get something like our solar system with 9 planets going around the sun. So that gives you a rough idea of how our planet formed. And we are really made from the dust between the stars. The stardust here is what God used to create new stars, new planets, and us. So this is an image now, right, yeah. Okay, so I had to tell you the story of that because I wanted to tell you about the large number of planets being discovered around other stars. I was showing you diagrams there. This is a diagram too, but this is a diagram based on a whole lot of data we have of actual stars out there with planets going around them. This is something that was not known. When I was a young graduate student 20 years ago, no planets had been found yet. The first planets were found here in '96, like we had 1, 2, 3, 4, 5, you know. And then some new instruments came online, more and more planets were being discovered. The Kepler spacecraft was launched and greatly added to our numbers of planets. And then earlier this spring, February, they announced the discovery of a whole bunch more. We're now up to something like 3,000 planets known around other stars, and more to come. And I mean, it's an extravagant abundance. So there's planets out there that we didn't even know existed. I think God creates a whole bunch of things beyond, I mean, he doesn't create just for us to enjoy the universe. He must be creating for his own pleasure at seeing all these planets and galaxies out there. So that's an extravagance of God's creation. Of those planets, they estimate that roughly 20% of the planets out there, they now have discovered enough that they can do some good statistics. They estimate roughly 20% would be about Earth mass and about the right distance away from their star to have liquid water. Not that they have liquid water, but they could. The water wouldn't instantly freeze or boil away. And that puts them in the habitable zone, it's called. 20% of these, of the 3,000 already, that's a significant number, but 20% of all the planets in the galaxy, we're talking millions of planets that could be capable of having liquid water. And if they have liquid water, perhaps they have bacterial life, and maybe they have higher forms of life as well. So astronomers are busy looking for bacterial life on other planets. That's the cutting edge of astrobiology right now. There have been searches for extraterrestrial intelligence, for radio signals from intelligent life forms out there, and those have discovered nothing. But what we're hoping to see is planets around other stars where there is, where you can detect the atmosphere of those planets, and the atmospheres of planets are transformed. Earth's atmosphere was transformed by the presence of bacteria that could produce all the oxygen we see. So we're hoping to do measurements of the composition of atmospheres out there and infer then the presence of bacteria. So it'll be really interesting to watch. If you want to know more about life on other planets and theological speculation thereon, there are some authors who've written some interesting books on that, Christian authors. C.S. Lewis has a space trilogy. Maria Doria Russell, I think I'm saying that right, has an interesting one. And there's a couple others out there. Science fiction is a great place to speculate about all of these things, including the theological aspects. Okay, all right, moving along. Okay, so then, so we're talking about all these stars. So by now you recognize the signs of a nebula. The red glowing gas is hydrogen, the smoky feel, and there's a particular star there. And what this points out is what happens at the end of a star's life. I showed you how it formed, but stars go through a whole life cycle and they come to the end, they run out of fuel, and they go out in a flash. That is the after image of a supernova. So not all stars end in a supernova, but some do in this dramatic explosion. And all of the material that was in the star is now, not all of it, but a large portion of it is now spread out into the surrounding nebula. I like this as a sign of God's power. The energy from one of these supernovas, when it's at its peak, is as much energy as coming off of a whole galaxy of stars. It's incredible. So in the Bible, we read that God is a powerful God. And you think of various images of power, you know, earthly political power and things. But then you look at something like this, you go, oh, power, I get it. You know, like incredible power. And it also shows the cycle of life and death that I mentioned in an answer to in an earlier talk today. That God doesn't seem to create things to last forever, even in the cosmic lifetime of billions of years. We're seeing things, they might last millions, you know, these stars, but then they come to the end of their lives too. All right, so I wanted to say a few words here about fine-tuning. So we start talking about a life elsewhere and how the universe is suitable for life. We start to think, well, you know, the universe, it turns out to be fine-tuned to make just what life requires. So life as we know it, what does that require? It requires a variety of atoms, but life as we know it is a big caveat. You know, you could speculate on all sorts of bizarre forms of life, but this is still a pretty general statement, that life requires a variety of atoms. If the only thing in the universe was hydrogen, it's a little hard to imagine what kind of life you could have. So we need a variety of atoms, and atoms are made in stars. Those fusion reactions at the centers of stars are producing things like carbon and nitrogen and oxygen. And then when those stars explode, they spread all of those gases out into the interstellar medium. Then the clouds collapse back down and are formed into the next generation of stars. Life as we know it also requires a stable energy source. So we can't just have a flash in a pan of a star. We need a nice long-lived star that can warm a planet. So how do you get a long-lived star? Turns out there's some basic physics parameters that have to be set to just the right values, or you wouldn't even be able to have stars. So one of those is the strength of the gravitational force. In a star, you have a tremendous amount of mass, and it's all held together by gravity, but it doesn't collapse all the way down to a point. Instead, there's gas pressure that is upholding it. So there's all the gases are bouncing around, and you get this equilibrium, gravity pulling it in, gas pressure pushing it out. And that gives you the nice equilibrium state of a star. Well, if gravity was too strong, it would pull all those gases in really tight, and they'd still bounce around a little bit, but they wouldn't get out, and the fusion would happen so fast, the stars would just rush through their lives, and there'd be flash in the pan. If gravity was too weak, the stars would be just very diffuse, they'd be lazing around, they'd never get around to fusion, and we wouldn't have any elements, we wouldn't have energy production. So gravity has to be just the right level. You can play similar games with these other parameters. You need special settings of these different things in order to be just right for atoms to work, for forces to work, for stars to work. And then the kicker is there's this special quantum states in carbon and oxygen. For the fusion production of those, if the states were just slightly different, you don't have to even know what a quantum state is, but just to give you a flavor of it, if it was set to a slightly different level, you would never be able to fuse and make carbon. And carbon, okay, we eat carbs and stuff, so there's a lot of carbohydrates in your body. Our bodies are made of long chain molecules of carbon. Carbon's really good at making long chain molecules, and they're tremendously important for every aspect of biology. Without carbon, it's, well, we could come up with other atoms, but this special quantum state allows stars to produce lots of carbon, and for some of that carbon to turn into oxygen, but not all of it, so that you get a nice mix of carbon and oxygen, which we use a lot in our bodies. So these properties are set just right for life. And Christians are not the only ones saying this. There are many atheists and other faiths of astronomers and cosmologists who point out these same things, like, wow, look at this. This is amazing how these are set just right. We could imagine it being different and it would all fall apart. And for me, that points to a designer of the universe who's crafted and designed and set the parameters just so from the very beginning, so that they could hold the same values all the way till now, but then lead to all the beautiful structures that we see. Okay. So, moving beyond our galaxy to the Andromeda Galaxy, which was mentioned. So back to the paper plates. Okay, turn the lights back up a second. So, you probably can't see that. You can't see that. Okay. Anyway, here's our Milky Way galaxy. And on that scale model, Andromeda Galaxy would be about over here. Okay? So Andromeda is similar in size to the Milky Way. It's tilted a little bit relative to us, and it's about that distance. So Andromeda is our sister galaxy. It's about the same size as the Milky Way. It has hundreds of billions of stars like the Milky Way. This shows the beautiful spiral pattern. So you can see the dust swirling around, like so. And so those are the spiral arms of Andromeda. You also see two satellite galaxies. You can see one there and one there. Those are smaller galaxies. Just like I said, there was the one small satellite of the Milky Way. Well, Andromeda has its own satellite galaxies. And it is about 2.5 million light years away from us. So that means we're seeing it not as it is now, but as it was 2.5 million years ago when the light left Andromeda on its way to us. So there's some of the science fiction speculation is about what it looks like right now, because we don't know. It'd be fun to, maybe it's disappeared. So that's 2.5 million light years away. Now, I haven't really justified that distance to you. I could, if you want, explain all the steps in the reasoning of how we know it is at that distance. Measuring distances in astronomy has been a huge project of the 20th century, and we are finally able to measure them with a fair amount of precision. But it's been a big project, because you can't just run a measuring tape from us to the nearest star, you know? Like, how do you do it? It's a whole lot of triangulation kinds of things, and anyway. I wanted to show you one example here of how we then leapfrog from the Andromeda Galaxy out to much greater distances, just as a visual example of the distances involved. So first of all, for scale for Andromeda, how it looks in the sky. This is how large the full moon would look in front of Andromeda. So you all know how big the full moon looks in the sky. If Andromeda were this bright, it would look this big. As it is, you can see the little faint smudge of the center of Andromeda. If you're at a really dark sky site and you know where to look, you can see a little smudge. But if it were much brighter, it would look this big. And it would look much bigger than the full moon, which I think would be so cool. If you went out at night and you could see this big, beautiful galaxy sitting there, oh, that'd be great. You can't, but it'd be cool if you could. So that just gives you, that's how big it is. When you're looking at our neighbor paper plate over here, it's pretty big on the sky. Now, in my research, I studied galaxy clusters. So I just studied much smaller regions of the sky, like this. Can you see the little orange square? Yeah, little regions of the sky, okay? So we better zoom in on that so we can see it better. There it is. This was a galaxy cluster. So what all of these smudges here are entire galaxies filled with billions of stars, like Andromeda. Some of them are very big galaxies. This one and this one are supermassive galaxies that are hundreds of times larger than the Andromeda or the Milky Way. But there's also some more typical ones here, like this one, that one, that one. Do you see the little spirals there? You can't see the spiral shape, but you see this edge-on shape that looks just like this one. Okay, so there's Andromeda, and then there's a galaxy just like Andromeda. There's several of them there. And now picture how small that thing is inside of that little box. And you can see that this one looks hundreds of times larger than that one. And that gives you an idea of how much farther away it is. And the calculated answer is it's 1.4 billion light years away to this galaxy cluster. So we're seeing it as it was 1.4 billion years ago. And no, I can't grasp that on a gut level any better than you can. I just get very familiar with it by looking at you start tossing around millions and billions in your everyday life as an astronomer. So that's a visual way to show you the great distances and ages involved. In my previous lecture, I talked about how we then interpret Scripture in light of that. How do we read the Bible to understand when the Bible talks about 6 days versus us talking about billions of years? And so I won't review all of that again, just suffice to say that I see Scripture as teaching the who and the why of creation. Who made it and for what purpose, more than the how and the when. God gives us the natural world to look at to determine the how and the when. Okay, so got our two galaxies, and they're being attracted by gravity. They're going to collide. And they're going to collide, it's about 3 billion years in our future. They're on an infall track. So mark your calendars. 3 billion years from now, they're going to collide. The goat and the rat were talking, and they said, did you know our galaxy and Andromeda are going to moving towards each other, and they'll collide in 3 billion years? Hope you didn't tell Pig, our friend Pig. What's wrong with telling Pig? Sometimes he has trouble conceptualizing big numbers. I loved you all. So, yeah, you know, and it turns out though we're not going to die. When we collide with Andromeda, it's instead going to be a glorious light show in the sky, really. It's very unlikely that our sun would hit another star. The one to worry about is about 4.5 billion years from now, our sun will become a red giant and will burn up the Earth. So that's the one you want to watch for. Unless Jesus comes first and renews into a new heaven and a new earth, which I believe will happen, I just don't know when. Okay, so our galaxies are on a colliding course, and now we need the lights back down. So these are the antennae galaxies, and they have already collided once. They made one swoop past each other, and they're still in the process of scrambling into a single body. You can see the two galaxies here, and can you see a faint arc coming off? Oh, just barely with this projection. Those faint long tails are bits of the galaxy being pulled out. And if we zoom into the center here, though, we can see all sorts of things going on. And I had to show this picture because it was used in the advertisement for my series. And again, just a glorious, beautiful image of just beautiful colors here. This is the remains of the center of one galaxy, and this is the center of another. There are this red stuff here. Okay, there's actually 3 different colors going on here from 3 different telescopes, and it is showing us. Well, the blue light is X-rays from the Chandra X-ray Observatory. The red here is displaying infrared light from the Spitzer Space Telescope, and the yellow-browner stuff is visible light from the Hubble Space Telescope. There's 3 major pictures all combined here together, and it's showing us way more than our eyes could see. Okay, our eyes cannot see X-rays, our eyes cannot see infrared light, but satellites and telescopes can, and when you use those instruments, then we can display it in a way that our eyes can see. So it's showing us, well, first of all, you couldn't see this at all without a telescope, and now we can see it in full spectrum here. So we know that this red region here is where there's dust between the stars that's glowing. You see some faint blue light coming off of this. That's the X-rays from very hot gas that's the remains of a whole bunch of supernova explosions. So all sorts of stuff going on in this image. And this is one reason I fell in love with astronomy, is because it's beyond what our eyes can see. And there's so many things in our spiritual lives that are that way too. It's beyond what we're seeing with our eyes. Jesus became incarnate so we could see him with our eyes and touch him with our hands. But he then revealed a whole world to us of God the Father and the Holy Spirit that we can't see and touch, that go beyond that. Okay. What's the time for? Oh. All right. So we've talked about stars and planets and galaxies and fine-tuning. Next up, the universe as a whole. Did you see that? We'll just run that again. So what I'm showing here is a whole bunch of galaxies and how they are moving apart. So each of those galaxies, the little photos here, they're all from Calvin College students. Send your child to Calvin College, they'll get to make a picture like this with our telescope. But this is the discovery that Edwin Hubble made with some collaborators in 1929, saying that galaxies are moving apart and that this represents the expansion of space itself. The entire space is moving apart and carrying these galaxies along with it. So you rewind that back in time, and what happens? The galaxies earlier in the past must have been much closer together. So we're doing a thought experiment here. If they're moving apart now, then in the past they must have been closer together. And in the very distant past, they must have been all smushed together on top of each other in an incredibly hot, dense state of gas. The whole universe was in a hot, dense state. Okay, so a few people watch The Big Bang Theory on network television. So that TV show has some incredibly funny geek humor in it. It also has awful sexual mores, and I can't hardly watch it anymore, but the geek humor is really funny and always accurate. But it's true, the whole universe began in a hot, dense state, and that is what scientists call the Big Bang. Now, before that, when that hot, dense state at the beginning, that let off a whole bunch of heat radiation, and that heat radiation is still traveling to us today. We can detect it in the sky. And when that was discovered in 1965, astronomers became convinced that there was a beginning to the universe. Before that, there was quite a contingent who said, no, the universe is in a steady state, it's infinitely old. There can't be a beginning to the universe. That sounds too religious. But Georges Lemaitre was a Belgian Catholic priest who had no such qualms about the religious beginning to the universe, and he explored some of the general relativity developed by Albert Einstein and calculated that, yes, the universe could have had a beginning in this state. And once this heat radiation was discovered from the beginning, astronomers were convinced. Did they all become Christians? No. Instead, they started saying, now we know how the universe started, we don't need God to start it. I'm like, no. Didn't we just say a scientific explanation does not replace God? Just because we understand the early times of the universe doesn't mean that God's not involved. To me, the Big Bang is not a bad word. It is a scientific model that describes how God governed the early universe and how God brought all of this structure into being. So when you rewind the universe like that, we can count back how long ago was it? And we're getting better and better at that. When I was a young graduate student, it was, 10 billion years, 20 billion years, somewhere in there. That's like a factor of 2 off. We really had we knew it was billions and not thousands. Nobody was considering thousands at that point. But how many billion? The latest results, 13.817 plus or minus 0.048 billion years. Can you believe it? That precision is incredible. I mean, we're down to less than 1% precision. We never thought we would get to that. I mean, we just, kind of get, cosmology, it's always like within a factor of 2, good luck. And here we are down to this level of precision. It's incredibly exciting on a scientific level. And it's conclusive that saying that the universe is ancient. And that always reminds me of the Ancient of Days. I don't believe that God is part of our time and space. I believe he's beyond that. But considering the incredible scope of the time in our universe reminds me how ancient God is and how long-lived. So looking at that heat radiation of the early universe, I'll skip all the details, also tells us something about the ingredients in the universe. And I'd be happy to explain this more another time. Well, I'll explain a little bit now. What we have found is that the universe is mostly dark matter and dark energy, and it's only 4% atoms. Everything in this room is atoms. We're made of atoms, the air, the room, it's all atoms. But when we look out in the universe, well, the stars and planets are made of atoms, but there's also all this other stuff out there, dark matter and dark energy. So if you can bring the lights back up, I'm going to show a few pantomimes here. So dark matter we see it in our galaxy. We see that it's matter that does not emit light and it doesn't block light, but it has a gravitational force. It keeps the galaxy in orbit. What it does in the universe is it slows down the expansion. So I'm going to pretend my universe, my hands here are representing the universe. So the universe, here's the universe expanding, getting larger and larger. Great. So the universe starts off at a certain speed, and it could just keep going at the same speed, barring anything else stopping it. It just would keep going. But if you put a bunch of mass in the universe, if it's not empty, which it isn't, there's a lot of stuff in the universe, that has a lot of gravitational pull, and that's going to kind of try to pull things together. So you might start off fast and then get slower and slower, and then the gravity might actually pull it all back together until it collapses down. So the matter in the universe, you could start off fast, it would slow it down, and then the matter would draw it all back together until it collapsed again, if there was enough matter in the universe. And for a while we thought there was, and that the universe would have this expanding, contracting, cyclical thing going on. But then we found that there wasn't enough dark matter to do that. There was enough for it to slow it down, but it just kind of kept going, just slower and slower. Then we discovered dark energy. And that is a catch-all phrase for we don't know what in the world it is. Okay? We really don't. It's some kind of interesting energy field, but mostly we know it by what it does. And what it does is accelerate the expansion. So with dark energy in the universe, you start off at a certain speed and you get faster and faster until it's expanding so fast, everything in space is ripping apart. So we have some dark matter and some dark energy. So you put them both together. You start off fast. Let's see. You start off fast, slow down, and then speed up. So you start off fast, slow down, and then you speed up with the dark energy. And that's what our universe is doing. So we're currently kind of right near the inflection point where it's starting to accelerate again. So dark matter we have known about for a few decades, and scientists are getting closer to more and more experiments about what kind of bizarre elementary particle it might be. We're kind of narrowing in on it, and I hope in my lifetime that we'll have figured out what dark matter is. Dark energy, oh my word. We're getting some handle on it. We're ruling out some things that it might be, but it's still a big mystery. And one thing this reminds me of is just the unending mystery. This is what is so cool about science. I was speaking at a church, and a teenage girl and her dad came up to me, and they were talking about this and saying how, when you just first learn about space, you can look at the stars, and everybody just appreciates looking at the stars. And then you read a little more, and you learn about the solar system. Kids learn about solar system in school, and there's more to discover and go, oh, that's cool. And then PhD astronomers like me are studying these distant galaxies. Oh, we can figure out how distant galaxies work. And then along comes dark energy, like, okay, everything we just learned is only 4% of the universe. We've got 96% of it to still figure out. There's just always more and more layers. And I love that about what God has made this universe. So you never hit this wall and go, oh, that's it. There's always more to discover, and I think that's true of God himself as well. There's always more to learn about God's character. I need to talk, though, about the multiverse. So, our universe may be part of a large multiverse. It's hard to draw a picture of a multiverse. This is sort of one. I don't know how good that is at representing anything. First thing you need to know is there are many types of multiverse ideas floating around. Here are 5 of them. And here I'm recommending Brian Greene's book, The Hidden Reality. And that does a good overview of several types of multiverses. and as only a little bit of an atheistic worldview spin, not very much. So the first type here is just the fact that our universe is likely to be infinite in extent. So you keep going in our universe, going out and out, and you get beyond, you get way out there, and you still keep going, because infinity is, you just keep going, and there's lots of universe out there, and that already is incredibly vast. But there's more. The next one here is the inflationary universe, where other universes are causally separated, and they have somewhat different properties than us, and you get these bubbles. So this is an artistic representation of a multiverse, and so there's our planet stuck inside of this bubble, kind of representing our universe, and then there's all these bubbles of other universes, and each bubble has somewhat different physical laws, and there are many of these. Now, that sounds really bizarre, and for years I said, well, that's just wild speculation. And then I learned a bit more about the inflation model of the early universe and how this was a natural outgrowth of it. Like, well, okay, so there's some well-based, mathematical basis for this speculation, but it's still speculation. You can't go and measure the other universe. You're stuck in your own. There's no way to get over to the other one. So how could you possibly know there was another one? Well, then inflation got confirmed. So I have to tell you what the inflation model is next. So in the inflation model, here's the dawn of time, okay? This is a big question mark there. That's true. We really do not know how this got started. But a tiny fraction of a second later, you have a soup of quarks and other elementary particles, and then you have this inflation epoch. And inflation happens 10 to the minus 35 seconds it's a tiny, tiny fraction of a second. And the initial fluctuations here expand out to the size of galaxies. It's an incredibly rapid expansion. So what I was doing with my hands, this would be like, boom, and then it kind of continues expanding. In that first second, it would do a whole bunch, and then it would keep going after that. And in the level of bizarre things, this one's bizarre even to people in the business. Like, this is really, like, how many zeros do you need to talk about what you're doing in scientific notation? So it's highly speculative. It was highly speculative. Again, 20-some years ago, it was a bizarre idea, one of several bizarre ideas, meant to resolve certain scientific problems with the standard Big Bang model that I've described to you. There's the uniformity of the afterglow heat over the whole sky. How did it get to be exactly the same value? That's just one of the things that this is meant to address. And it does address them well. So you've got a scientific model. It's bizarre, but it explains some of the data. Okay, fine. But make some predictions. If you make some predictions that we can test, maybe the model will be right. Well, it did make some predictions, and some of those were confirmed quite well about 10 years ago. Then it went and it made some more predictions. And that prediction was dramatically confirmed in March. And this is a video I want to show you.
Let's try this again.
I'm sorry. Okay. So he goes on to explain more about what the discovery was. But did you see his reaction? It was 30-some years ago he came up with this model, one of dozens of models at the time. And the young scholar, as scientists, has come to him and said, we found it. And R of 0.2 obviously knew exactly what that was. It's the strength of these gravitational wave modes. And just stunned to discover that this was confirmed. So the look on his face, that he actually found this. His wife hugs the scientist, they've actually found it. I was talking to my friend Andy Crouch, who you may know of his work. He's at Christianity Today. He saw this video. He said, isn't it amazing how we as image bearers are designed to glimpse God's cosmos? And all the hard work that's put in by so many theorists and experimentalists over the years to make this discovery. and to have that joy of learning about the cosmos is part of what it means to be in God's image. Thank you very much. So a lot of people then say about the multiverse, we have all these different universes, all these different bubbles, and they have different physical properties. So, and you have lots of them. So then it becomes not so odd to think that at least one of them would have the properties set to just the right values so that life could exist. And of course, which one would we be in? We're in the one where the properties are set just right. And so it appears then that the multiverse could explain fine-tuning, and now we don't see some special crafting of our universe just for us, but instead we're just one of many universes and we happen to be in the one where things worked out. However, the multiverse itself actually needs to be fine-tuned. It has to be capable of producing multiple universes. It has to be capable of producing them with a range of physical parameters that include the ones relevant for life. So I don't see the multiverse as getting rid of explaining away fine-tuning. I think it would explain some fine-tunedness, but not all of it. So thanks for asking about that. Robert Mann is a cosmologist who's been thinking a lot about theological implications of the multiverse. If I think of other names, I'll come and tell you. But there are some, mostly people in the sciences are thinking about it, but I'd love to have some more theologians digging into that question. What is our significance based in? How it's not, I mean, we tend to think, bigger is better and more significant, but there's no theological basis for that. And C.S. Lewis talks about that, size doesn't mean anything. And so what is the basis for our significance? And I see it as, this is one thing I didn't get to here, but as coming in, coming in the incarnation. That Christ was incarnate here on earth. Out of all the planets and all the universes, our God came to this earth. We couldn't be more significant in that perspective. So.